Good morning. Happy Friday. I forgot to set up my tablet, so I've got to turn that on so I can see the chat. But other than that, it's going to be a pretty normal Friday morning. I later today, I'm actually taking my team out at work for a offsite. So it's going to be the first offsite that I think everyone other than the CTO, who is also sort of like leading this team, has been involved in. So I'm super excited about that. Gotta wait until internet loads for that. And I mean, so like those things are going on. Weekends coming up. That's always good. And of course, I got accepted to talk at the Develop Denver conference, which is really interesting because I had submitted a traditional talk and that wasn't voted in. So it wasn't popular enough for it to be accepted as a normal talk. Which is too bad, but I'm not too upset about it because they then had an opening for the streaming section. So if you haven't seen the update video that I put out, I am now going to be doing a live stream at Develop Denver, the conference. That's going to be on August 16th. So that's a Friday. And it's going to be something like 10 a.m. Mountain Time. I can't remember exactly off the top of my head, but obviously I'll be tweeting out about this, and I'll be setting up an event in Twitch and all the fun things about that. And I'm gonna get 45 minutes, and I'm going right before CJ's Coding Garden stream, and he's getting this. Everybody's who's going is getting 45 minutes. That's how long the talks are. So I decided that I want to go do something pretty big. And I've been wanting to learn machine learning, deep learning, AI for a while now. And so I picked up this book. And in fact, I ordered this book before I even knew that this was going to happen, because my initial plan was to finish the project idea holder and then go through this book and display do all the exercises in Rust, which I probably still will do eventually, but because of the talk, I figured that doing this in the JavaScript will be, or node.js will be a little bit better of a choice, because, well, that's what the majority of people going to the conference is. And this is mainly going to be a live, there's going to be a live audience there. I'm going to put big screen on so you can see the title of it a little bit better. So I really do like this book so far. I'm in the middle of chapter 3 right now, and for the most part, the exercises are making sense. The text is simple enough for me to understand. I suppose it'd be good to give a little bit of background information on me, like math-wise and education-wise. So I don't have a math degree. I am actually dyslexic, which did not help my math in college or high school. So basically, I got by with the bare minimum. The only calculus that I was able to take and pass was, I can't remember what it was called. It was the intro. It was the beginning calculus for computer science class. There was a huge number of like binary and logic gates, and it was the first math class I've ever taken in my life that I was able to just breeze through it. And I barely had to do any studying. I didn't really have to think about it. It just locked in my head and worked. And I don't know if that's the type of calculus that's helpful here. I know that there's a lot of other mathematical things that we have to do. There's also a lot of very complex words that are used to describe these. And that's why I like this book the most, actually, is because it's avoiding using those words until you learn like what you're doing, if that makes sense. So for example, they don't even mention, I just got to the part where it talks about a matrix and doing some matrix math. It doesn't say that it's a matrix. It waits until you've coded that and then says, oh, by the way, that thing you did, it's an array of arrays. That's a matrix. The other thing is all the exercises are in Python. That's just the writer's choice. That's also because Python has NumPy, which is a library that lots of scientists use to do advanced mathematical things. I am purposely not using NumPy. I'm doing a lot of the exercises off stream in Python, and then here I'm going to do like sort of redo them kind of, sort of, but not exactly, because I don't want to run into any copyright flagging rules in JavaScript. And I'll change some things around, but you'll still be like go through and reference like what exactly I'm trying to practice. I don't know if I have any other introduction type stuff besides that this is going to be probably slow going. I'm going to be trying to describe what I'm doing because I found that that's a great way to learn. And if you know anything about deep learning, machine learning, I guess I should put a pause in there. Deep learning, which is a subset of machine learning, then please speak up and let me know what I'm doing wrong or if I'm doing it right. So I've got a brand new code repository started up in the Brooks Builds section. I should skip to chapter 3. Where is that? Here. And I will share that with everyone. So this repository is where all the code is going to go. I'm just going to do everything in JavaScript in here. If you want to follow along with the more like the actual exercises as I'm doing them live, I have them over on my personal GitHub repo, and that is not in Brooks Builds. That's where I am sad that they no longer do this in order. Here it is. So I just named this after the book, so Grokking Deep Learning. The book series is excellent. The other book in the series, which I also highly recommend, is the Grokking Algorithms, which I don't remember what language they're written in, but the examples have a lot of just pictures in them. So it's sort of like is a light introduction. Let me see. Let's go back to, oh, of course. All right, then let's create. We're gonna so chapter 3 is the first chapter that we have anything to do with code in here. And the very first thing it wants us to do is create the simplest neural network in existence. What's really interesting is they do that in the first few pages. So that way they can, they can get you creating something immediately. So we'll do that. We'll call this simplest neural, is that how you spell it? No, it's the other way. Neural network ever .js. All right, so to begin with, we're going to create our function. So function neural network. We're gonna have inputs. The input, like, it's gonna be a number potentially, or it's gonna be an array. It really depends upon how this neural network is actually made. For this super simple one, like this first thing that it introduces us to, it's actually just gonna be a number, but I'll sort of show it after I write this out. And then we're gonna have the weight. And we're going to get const prediction. And all it's going to be is simply multiplying this input by the weight. And then we're going to return the prediction. As I said, this is the simplest neural network ever. And I think this is something that kind of helped me, because I was looking at some of the more official learning for deep learning, and it just immediately goes into the advanced math to create like a neural network that actually does something for real. And this kind of helps me realize that, oh, this is literally all that's going to be happening in our neural networks, just at a lot more complex system. Well, so we need our input. So we can, we'll say input equals, and we're going to have a series of these. The book actually used some pretty funny ones, but let's say I'm trying to predict, I don't know, what should I pretend that I'm predicting? I say pretend because this is not actually going to be a real prediction. Let's say how hot it is. If any of you have any ideas or want me to change it, let me know in a chat. So I'm not going to say input. We're going to have const temperature, and let's say it's like 95 degrees, 100 degrees. And what's really interesting is everything they did was small, like smaller numbers. So I will be interested to see how this changes things. So 95, 100, 105, like 85. These are our degrees in Fahrenheit. And which means that we're going to have an input, which currently is just going to be set to the first temperature. And we're also going to have a weight. And this is going to be, the way a book described it, and the way I'm sort of like trying to think about it, is the input is the actual thing, the actual data point. And the weight is our scaling. The temperature is not in floats. Also, hello stacking. You are correct. They're not in floats, although it's JavaScript, so they are in floats. Because, you know, why not? We can say this. We can just make these all floats. So we can just choose a random one, like 0.1. And I don't know why, like, I would choose 0.1. I haven't gotten far enough into the book yet to know what a good initial weight is. I'm just sort of taking the weights they're giving me and just going from there. And then we just run the neural network. So const prediction equals neural network. We're going to pass in the input, and the weight. And we'll just log the prediction. Okay. Make you come down here, and we'll node the neural net. Yeah, the simplest neural network ever. And that's what we get out of it. So that's our prediction. Now, if we want to make this a percentage, which is what the book is making them all, then I think it's our weight that has to change. So I think I can just make this smaller there. And it brings things down. So I don't know if this means that I don't. What that really means is like doesn't help us at all. Although I guess what we can say is it's like we would say the inputs are the average temperature, and then we're trying to determine if it's if like the new temperature is gonna be right. Figuring out like what this is, that's like the key point. Now, what the book talks about is like predicting baseball, like a baseball game, and so it gives something like the win-loss average, and it's using really silly numbers, and then something like, hey, let's take a look at the number of fingers that all the players have. So if I do something like that, which is not actually the example they have, it's just close. So if we have a number of fingers, normally you would hope that everybody would have 10, but let's just say we have something like, 10, 9, 10, 9.5. And then we grab the first one. This is closer to what they actually, like the numbers they actually showed. I should save. And then it's predicting that our win chance is 85% based upon this. The great baseball strategy of '89. You remember that, of course. That was the earthquake in which all the players lost their fingers. Of course, this neural network is completely useless because if we move to the next day, where the average number of baseball players have 10 fingers each, the weights don't change. And so therefore, the prediction, yes, it'll be a 1.0, saying now, and I can actually show this, so like this is the next day. But it's just saying 100% chance of there being a win. But that's not really predicting, it's just us making up numbers. So moving on, then it becomes more interesting because we get to start saying, well, what if we want to use multiple inputs? So if I continue this, we have number of fingers is one of these inputs here. We also have, okay, so we have number of fingers the players have. We also have whether or not there was a, like the game was won or lost. So win, loss, average. So it's the win-loss average of the team, not like 1 or 0 was it lost, which I think I guess it makes sense. I don't know if it could also be the number of games won so far. or if it really is that just the end number. So let's say they have a 0 dot like 65. So we start with a 65% winning, and then we move up to 0 0.7, 70%, 0 0.6, they lost, 0 0.5, and then 0 0.55. So over time, they're winning. Actually, over time, they're losing, and then they won the last game here. And the last thing that we can pull in is let's have like something like the number of foul balls. So const number of fouls the sport doesn't really matter here either. It's kind of funny. There's a live book version of this with which people can leave comments on, and there's a bunch of non-Americans commenting about baseball, asking what these numbers mean and why they're important. And of course, they're not important. These aren't real numbers; they're just sort of made up. But it does. It is something that like we have to remember not to get caught up on, and when we get to real data, that's when we have to worry about it. All right, so number of fouls, and this is trying to make the number really low. So let's say that there was like 25 fouls. Let's divide that by 10, and we'll say something like 2.5. Then maybe there was like 10 fouls. And these are like per game too. And then we can do, maybe there is not, we can do 1.5, 2. This is 4. Let's just keep these at 4. So 1, 2, 3, 4. 1, 2, 3, 4, and 1, 2, 3, 4. Okay. So we have these inputs, and we're going to predict if the game was a win or a loss, which is a little bit interesting. When we have our win-loss average, we would be able to tell, hey, the number went up from the previous time. It's now a win. But the computer has no memory, so it's not going to know that the previous number was smaller or larger. So that's its job, is to predict that. And our input now is going to not just be like one of these, but rather an array of these. So we'll have the number of fingers, 0. Then we'll have the win-loss average, 0. And the number of fouls, 0. And we need to therefore have weights that correspond with each of these, because the weight for number of fingers has to be unique. It can't be used against these. And from what I understand, when we later on make this algorithm do more than just like a single prediction, but it's rather just training and going through all of them, the weights are going to be the thing that changes, that the computer controls. So it says, hey, the number of fingers, that we believe that prediction was completely wrong. Therefore, we're going to adjust the weight down for it. So we take that into less account. Because this is simply just a mathematical product operation here, it is as simple as just saying, okay, weight, you go down. Now this number will have less effect. So this also has to be an array. And we can do something like 0.1. That's what we take into account for number of fingers. We can take something like 0.9. That's pretty important. That's much more important. and 0.2 for the number of fouls. That's a little bit more important than number of fingers, but not that. We then pass this into the prediction for the neural network, but we have to now change this because this is an array and this is an array. So this introduced this idea of the weighted sum, which they call it the weighted sum. I think that's an actual computer science term for this operation. It's also known as a dot, which makes it a little bit confusing. So I'm just going to call it, we're going to call weighted sum and pass it the input and the weight. So that means we now need a function weighted sum, which takes in it. So this takes in just an array and an array, and it's going to do, I should probably call this array 1 and array 2. Okay. And we're going to do something called a weighted sum across these, which is really just that product that we had before, and then adding them all up together. So the slow, steady way of doing this would be getting the, doing a multiplication of this. The other thing that this reminds me of, and the book does verify is they call these vectors. And for any of you who remember when I was making games with Lua or Rust, we also called these vectors too. Although we would call these like a 4D vector because there's 4 numbers in them. In reality, we might have a ND vector with unknown number of them. The key is that these all must be the same length because each weight, so this is a weight, the first weight has to be multiplied against the first input. So if I call these vectors, so vector 1 and vector 2, the first thing that I want to do with this is multiply the first weight against the first input. So vector 1 position 0, vector 2 position 0. And if we remember, there's actually a vector math for that. So function, I think it was vector multiply, where we're going to take vector 1, vector 2, and we're going to return a single new vector. I'm going to do this functional style. So we're not mutating one of the vectors. We're just returning a new vector here. So first thing, const result. I guess call this result vector. And it's just an empty array here. And can you hear that? There's a dog next door barking. I think you probably hear it just barely. Okay, so we have like the basics of this vector, and then we're just going to push in so it's in the same positions as we go throughout. The other thing is that these absolutely must be the same length. You thought it was a chirpy bird, though it's one of those small dogs. I don't know exactly what breed it is. Maybe a Bichon Frise. It doesn't usually bark like this. I think there's a squirrel outside that it's barking at. All right, so they absolutely must have the same length too. So we'll go and throw. So we could just do a quick if. So if vector1 does not, vector1.length is not exactly equal to vector2.length, then we just want to throw a new error, and vectors must be the same length. And then we can move on. So we have our result vector here. We're now going to iterate through and generate this. I'm actually thinking, well, I guess for right now, I'll do this with the for loop style, but we can refactor this to a reduce because we're just creating one of them. So if I do a for let index equals 0, so starting with 0, index is less than vector1 dot length, and then index equals index plus 1. Then all we're really going to do is just push the result into here. So result vector dot push, and then it's going to be vector1 of index times vector2 of index. And then we'll return the result vector. So we can verify this works first. We can just simply call vector multiply, and we'll pass in 2 arrays. So 1, 2, and 3, 4, 5, and 6. So we would expect a single array to come out here that is 4, 10, and 18. And that's what we got. Does JavaScript not have a plus plus operator? Actually, it does have a plus plus operator. I just got into the habit of doing this from Lua, and I kind of like it. Sometimes I'll do the plus equals. I just find myself rarely using plus plus anymore. So this is going to give us that product. We can now use this inside of this weighted sum function. Although before I do that, let's refactor vector multiply to be not using a for loop like this. A reduce is probably a better, so a reduce would work really nicely. The problem is we have this like vector1 and vector2, but I think we can do this because we verified they're the same length. We're going to say this, vector1 dot reduce. We're going to take in the reducer. So this is going to be our the result, and the next item. So I guess like the next, and then we can get the index. We don't usually go for index like this. And we're going to return the result plus, what is it? Next, I should put these in parentheses, next times vector2 of index. So this might look a little bit strange, and if you're not familiar with arrow functions, this is just auto returning into result. So we're just taking whatever result is, and the return value is going to go into the result the next time. So it's the next is the next value, so it's going to start with 1 and then go to 2, and then go to 3, and then we're going to grab the 4, 5, and 6 from this vector 2 index. And before I forget, we have to start the result off with an empty array. And then we'll return a result vector. So this makes it a one-liner. Well, that didn't work. Oh, right. Okay. So we, this just added them together, which I totally didn't want. I want to push. So it's actually going to be result.push. And these things in here. Let's try this. Oh no, it didn't like that at all. All right, what is result? Result is supposed to be an array. I'm trying to set that up. Result.push is not a function, meaning that result isn't getting this first array here to be a function. So it's not what I wanted. Let's start over this. Let's make sure I didn't screw this up too badly, which I think I did. All right, so vector 1, we know it's an array. We, I guess like we'll start with results, the next, and index. And let's just begin by console logging results, next, and index. And I want to put in this empty array to start with. So the first result should be an array, and then after this, every result should be undefined. Next should be the 1, 2, and 3, and index should be 0, 1, and 2. Thanks. All right, so that worked. We have an array, 1 and 0. So that would be array, 1, and then 0 is the index. Then we have undefined 2 and 1. So that worked. And then I think we have this console log here, which is undefined. So knowing that, whatever we return here will go into result. So the very first result is an array itself. So we can say result.push, and then we have next times, and then it's going to be the other vector. So the vector 2 of index. No, okay. Why isn't result an array? I thought, I could swear we saw that it was an array. And that was what we were, that's what we were putting in. Unless it's like not an array for like the last one. Sort of makes me question if I know no reduce, but I've done this before. I guess I could also for each, but that makes me feel bad. So oh, you know what the problem is? I totally forgot. I'm not returning the result. I need to return the result. So this actually needs to be, I was trying to do it in one line. I don't think I can easily do this in one line because the push doesn't return an array. So I need to down here return result. That goes there. You come down here. This should work. 4, 10, and 18. All right. It makes it look a little bit nicer, but it's a little bit sad that I can't do this all in one line. Okay, so that brings us back up to weighted sum. So now we're going to use the vector multiply as part of the weighted sum, which all that means is that we're going to get this. We're going to get this this array here of the product of the two vectors, and then we're going to add them together. So we'll say const product equals, it's really going to be the vector multiply, and we're going to hand it vector 1 and vector 2. Once we have that, we're going to get the sum. So const the sum is equal to, and I might as well just do this all in one reduce here. So we're going to return, it's going to be product.reduce, and we're going to get the sum, and then the next number. And this one I can auto return. So basically it's going to be sum, we're going to return sum plus next. And we're going to begin with 0. So let's say I wanted to call weighted sum. So I'll do that down here to test it. So building these out with automatic tests would probably be an extremely good idea. And when I do the actual conference talk, I'm definitely going to have automated tests that are already pre-made out for it. So I just have to fill in the functions, and then it will tell me if it ran properly. So weighted sum, let's just pass it this one array. So this should be 1, 3, 6. What did I get wrong? Vector1.length does not equal vector. Oh, so the vector 1 weighted sum. Oh, I do need, silly me, I do need to pass in 2 because it's using the other one together. So that is 4, 5, and 6. What did I do wrong this time? That's 2 arrays. They're the same length going into weighted sum. So vector 1 and vector 2. We're then going to call vector multiply with both of those. So 1 and 2. So vector cannot read property length of undefined. So these are both vectors / arrays. I guess what I could do is put a quick console log in here. So log, just to make sure that vector 1 and vector 2 are what I think they are. Oh, that should have printed out. Oh, wait a second. I'm still calling like all this stuff here. Let me make sure I'm only just doing this console log. So I'm getting, where's that other console log? Weighted sum. Oh, here, weighted. So we put this in here and we get 32 out of it. So that would be the product of these plus added up. So if we remember, this was 4, 10, and 18. So 4 plus 18 is 22, plus 10 is 32. So that is correct. So that can come back. So weighted sum is working correctly. We can now put this back to the prediction. And we'll get this prediction again. Our input is going to be this array of 3 things. So 1, 2, 3. And then our weight is an array of 3 things. We're then going, we might as well call this weights now. I probably should have multi-cursored that. So we're going to get the weighted sum with both of these, and then that will be our prediction is the added together of that. So this is going to be the prediction of, did we win the game? Can I read property length of undefined? So I'm passing in input, which, how did I do that? That's weird. I want just the array of all these things. There, that should be better. 1.935, whatever that means. And we can adjust these weights to try to make it more of a percentage. So we can say, okay, you know what? This this weight corresponds to the middle one, so the win-loss average. That's important, but maybe it's not that important. And it's possible that the number of fingers doesn't have anything to do with it, so that we could add like a 0 onto this and make it really small. And this number of fouls like has almost nothing to do with it. So if we save that and run this again, then we get more of like an actual percentage that we can then use. And then at that point in time, the computer might change this and say, well, actually, number of fouls had like literally nothing. We're gonna reduce it down to 0, and it won't even be part of this at all. And maybe we move this back up to 9. And that's how it guesses and changes. But that's apparently how we have multiple inputs for one single prediction output. And then, what was the next one? Oh, the next one was a single input, but multiple outputs. And I think the idea is that you still have 3 weights, but now the weights are corresponding to the outputs and not the input. So let's say we have they were using like win-loss average. So we can not use that. We can use number of fouls only. So if we have number of fouls, we're just going to grab the first one. So number of fouls. So the first game had 25 fouls. And our weights, we could start with something like this. We have 0.1, 0.9, and 0. And what we're going to be predicting is that with 25 fouls, did we win the game? So this could be, did we win the game? How many bats were broken? And so I could actually put this here. So win. Was a bat broken? Did a fan get hit by a ball? And so this is probably also down to like a 0.3, and this might be like a 0.7. Again, everything here has to change because we're back to our neural network just taking in a single number again. But an array is the weight. So we now need another function that's not a vector multiply or a weighted sum. What we now have is a single number that, I mean, I guess it kind of is a vector multiply, but it's the other type of vector multiply. And what did they call it? They called this an element. They called ELE_MUL. So element multiply. Let's see if this has it in here. That's one negative about the book is it doesn't have a good variable naming. The author is creating incredibly small names just to keep it on the page, which is a little bit, it makes it hard to really truly understand. Let's see. Oh, it doesn't really explain what that is. Yeah, it's just saying it's an ELE multiply. I'm going to call that like an element multiply. I don't know the proper word for that, so if you do know that, let me know. So we can run that function right now. So the prediction, this is going to be a single number, and this is going to be an array. So this is no longer going to be a weighted sum. We'll call this like an elemental element. I wonder if I should actually just call this a element, like a single element vector multiply. We're going to have the input that comes in and then the weights, and we'll create the function down here. So function element vector multiply. This is just going to be a single number and a vector. We are going to return a vector. TypeScript might be helpful here, is then I could document using like what types were coming in and returning to. Definitely Rust would be nice for this because I could just set all of the types. Okay, so all this really is just a new output, and we're going to multiply against each of these. That kind of is a reduce here, but it's also a map. So if I return vector.map, and it's really just going to be the next number, and we're just going to multiply the number times the next and return that. So let's say we'd not worry about that right now, and we're going to console log element vector multiply, and we're going to pass it an array. We're going to pass it 2, an array of 1, 2, and 3. So we would expect an array of 2, 4, and 6. All right, that does exactly what we think it would. So now we're going to run this, pass the input in, pass the weights array in, get the prediction, and that's what it is. And so here are percentage chances that our neural network, the most amazing neural network in the world, predicts that it was a 25% chance to win, that we had a 75% chance a bat was broken, and a 175% chance that a fan got hit by a ball. Now, I might be wrong. These might not actually be percentages. These could just be numbers relative to other numbers that we maybe not tried. So by itself, this may be meaningless. And let's see. The next thing, of course, is to combine these two methods together. So if we take number of fingers, the win-loss average, and the number of fouls, and so our input now would be the same array that we had before. So it's going to be the number of fingers, the first one of those, the win-loss average, and the number of fouls. We now want to get all of them, right? So we have 3 inputs coming in, and we want to get 3 outputs. We want to get 3 outputs coming out for each of them. I think that's how it works. So we want the 3 weights for number of fingers, the 3 weights for win-loss average, and the 3 weights for number of fouls. So this one would be, I already forgot. Well, okay, the number of fingers, and this is also for, did we, oh, was it like, it's not the same, it's, oh, it's like, okay, the outputs are going to be the same. So this is going to be, did we win? So we'll do that there. We'll have an empty array. Did we break a bat? Hit a fan. So that's what we're trying to predict here. Thinkalum, hello. What book am I using? The book I am using is this this right here. Grokking Deep Learning. It came out in this January too, so it's a fairly recent book. The other book in the series, Grokking Algorithms, is also excellent. All right, so this is, oh, you saw that in a machine learning reading list? Awesome. The main thing I like about it is that it's not using, like, for example, when it first introduces this math that we're about to go through, it doesn't call this a matrix, even though that's what this is. This is an array of arrays, which is a matrix. And this math is used all the time in games or positioning or all sorts of other things. But it can be really scary for people who haven't done it before. And the thing that has been confusing me, and I think last night I started figuring it out, is how these weights sort of correspond and why the math works. So if our percentage of the win for number of finger, it's, let's see, they actually have comments in it, which is going to be really hard for me to do. Yeah. The top going down are going to be the values for like number of fingers. So I'm not really sure how to easily show that. But we'll say, okay, the chance for win for number of fingers is, let's say, 0.1. We don't really, or like 0.09. We don't, doesn't matter at all. The weight for a win for the win-loss average is, that should be like a 0.9, pretty hefty. And the prediction for win for number of fouls is 0.2, let's say. And then we're going to do the same thing for break a bat. So I guess if I were to put this here, this first one is finger, win, and loss, fouls. It's a little bit hard to sort of like see that going down, but I hope that will stick in with GitHub and make it easier to see. And then we'll just do the same thing. So breaking a bat for fingers, that is probably like 0.01, like incredibly small. The win-loss, this is also like 0.1. And breaking a bat, if you're winning, this is like 0.2. Probably very, very small for that. Actually, number of fouls, we could bring that up. That's probably much higher. The chances of us hitting a fan, so number of fingers, this is probably 0.1. With a win-loss average, this is like a 0.1. And number of fouls is like a 0.9. That court kind of stays there. It's not perfect. All right, so once we have that, what's we have the weights and the input no longer match up, which is going to be a little bit interesting. So when we come into our neural network, we have an input which is a single array of 3 things. Our weight is an array of 3 arrays, each with 3 items in it. And this now introduces us to something called vect mat mul. So the mul is probably multiplication. The vect is vector. What is the mat mean? Let's see if I can find. Where is that? Oh, matrix. That's what it stands for. Vector matrix multiplication. So in here, vector matrix multiplication. We're going to pass in the inputs and the weights. And I think, yeah, that's how they just have it here. So new function. Vector matrix multiplication. We're going to take in a vector and a matrix. And the way this seems to work, all right, so again, the vector and a matrix are just arrays, and they should have the same length. So we have to do the same if here. So I can just copy this down. So if they don't have the same length, we're just going to throw an error immediately. The illustrations for this book remind me of Y's Poignant Guide to Ruby. Oh, interesting. I haven't read that book. I've not really used Ruby at all, but I really like books that have good illustrations in them, especially like with tougher concepts like this. All right, so we verified they're the same length. We then need, and this is where it sort of messes with my mind a little bit. They're doing this with, I mean, because it's Python, they have access to like less array methods. It feels like, but maybe new Python has those, and this is just they're not. They're used to older Pythons, and they're trying to make it really simple. We're going to have an output of an array of the three things. We're going to loop through the vector, and we're going to get the weighted sum of the first of each of the rows in the vector. So let's figure that out. We know that we're going to get, well, we can just return from this vector.map, because we're going to take an array of three things and turn this into an array of three things, but they're different. And so we're going to get essentially just a number. And we need to send, what is this? Oh, we don't even really care about the input, do we? That's really interesting. We care about the index. That's all we care about. So we're going to get the number. I'm just going to put an underscore in it because we don't really care about it. And what we really care is the index. So we're now going to call and get the response, the weighted sum function. So weighted sum. Weighted sum requires a vector. So we're going to pass in the vector, and we're going to pass in the matrix and whatever the current index that we're on for it. So that's going to be like this entire vector. And that will give us the win % chance, the break a bat, and the hit the fan array. And that will be returned into the neural network, and then we just return that. And that's all this book has us doing. So let's try it. Vector 1 is not defined. Where was that? line 30. Oh, yeah, this is just vector, length, and matrix. So you could just say vector and matrix. And so these are the results of our weights. This math, so this is as far as I've gotten in the book. I think, what's the next section that I'm going through? It's predicting on predictions. Neural networks can be stacked. And I think what that means is taking the output of one neural network run and passing it into the input of another neural network run. So then like new weights and then doing something with this. I don't know if we're actually going to do that in this book or if it's just going to talk about it. But this math kind of is throwing me for a loop a little bit. And I guess I think the idea is for each of these through, we're going to grab the input. So the number of fingers goes through first. It hits this vector matrix multiplication. So we map through. First one comes in, number of fingers. That's 8.5 in this case. We then do a weighted sum of the number of the input. So that's all three of these. And then this full line here. So that means 8.5, 0.65, 2.5. So vector matrix multiplication. Okay, so then we come up to weighted sum. I'm gonna hide these. We're then going to get the product, so it's a vector multiply. So that's going to be the vector 1. So we then vector multiply these. So that's here. So 8.5 times 0.09, 0.65 times 0.9. So it is correct. We can see like number of fingers was this one, the win-loss average was this one, and then the number of fouls is this one. And so that gives us, what is it? We did vector multiply first. So that gives us the result vector. We return that into here, and then we reduce and add these all up together. So all of those come up together, and that gives us our chance of winning. So I guess it makes sense. I think, obviously, if we then go through and determine, well, hey, we were wrong. We had a 1.85, whatever this truly means. I'm hoping the book eventually gets into the point where these output numbers have more meaning to me. And then I can say, okay, well, this is how I should tweak. This is how I should choose these numbers properly. Because right now I'm just sort of pulling them out of thin air. And then, of course, it repeats down. And goes through this again. So using the same numbers, we now determine, did we break a bat? Did we hit a fan? So it's really cool. You thought random guessing was how machine learning design worked? That's how I initially thought it worked. Going through this, I'm not completely sure that I'm not completely confident that that is accurate anymore. I'm thinking that the guess might be, or like it feels like it's random, but in reality we're the ones who came up with the initial weights, and the computer will take that and determine, were we right or were we wrong? And it will, the guess is going to be, should it increment or decrement these weights for the next data set that comes in? And slowly over time, as it compares itself to real world data, the weights theoretically should get better and like be more accurate. Then again, I don't know what kind. I don't know if there's multiple types of deep learning, and this is just one of them. But yeah, that's all I have. And that's as far as I've gotten. So I don't want to like read the book and just sit here silently while I'm reading it. We have 15 more minutes left, so it could be a little bit. We could end up a little bit early, or if you have any questions, I could go over this too. What is this called? This is matrix. Am I learning this for fun or for work or what? I'm learning this for, I mean, I guess it's for fun. I've wanted to learn this for a long time, but I'm also been invited to do a live stream at the Develop Denver conference, which is coming up in a month. So I kind of want to do something crazy and write a neural network from scratch live on stream. And first of all, I have to learn it. So that's what this part is for. Once I learned it enough to write like a basic neural network that's going to do something interesting, I'm going to write all the signatures of the functions out along with tests. We'll probably do that on stream together. To like actually do the thing, I erase all the code except for the function signatures and the tests, obviously. And then the live stream will be me explaining what I'm doing while writing those functions out, and the test can run to verify that I'm doing it right, with, of course, a backup of the entire thing ready to run just in case I screw up. I also would love to be able to write a game, like a very simple game, and have a deep learning network like this try to learn to play the game on its own. I think that would be a lot of fun for me to do personally, and then do that in Rust. Those are my goals. Yeah, no, I definitely think it is fun. Of course, there's always the argument that machine learning is here essentially. It's not even coming anymore, and it's important for us to know this, so that way we can either join in and like be the developers who are writing it, or we can at least understand enough of how all these algorithms are working that are affecting our lives, because there's a lot of companies that are going to use these to try to control us, so we can fight back against Skynet. Like Skynet is probably, ironically, would be a better case than I think what's coming. Not to be too dark. I think what's going to happen is a lot of companies are going to use these algorithms to try to manipulate how we work. Like psychologically. And if we can be cognizant of these algorithms and what they're really doing, we can maybe be mindful enough to not let it just completely mind control us. And by it, I mean the companies, not the algorithms. They're just writing the algorithms in order to do that to us. That sort of dark thought comes from, what is it, 21 Lessons for the 21st Century? It's a book that I read recently, which is very insightful. I actually liked it a lot. So if we've got nothing else, then I think I'm just going to call the stream early for today. So I don't have any. I pushed up all the changes. We can find it up here. Next time, I'll probably be creating another file. You're in a futurism discussion group that recently read Program or Be Programmed by Doug Rushkoff. It said similar things. Yeah, I think a lot of people are calling, alerting the warning bells for this. And my prediction, understanding how the algorithms work, is going to help us. Whether or not that's true is unknown. All right, we have I have this out there. I will share this link again with you all. And I'm also archiving these videos up to YouTube. I'll put the link to this this code in the description of the video. If you're liking what you've seen, and for the next month you want to sort of continue watching me, I'm doing these streams on Monday, Wednesdays, and Fridays. When I can. Obviously, sometimes something happens, like this last Monday, I couldn't make the stream. I tweet out the night before if I'm unable. I'm unable to stream. So with that being done, the next planned stream will be Sunday morning. That's not going to be a machine learning stream. Instead, I am mentoring a high school graduate in building web apps. So we're using PHP, Laravel, and Vue for that. We'll be back to this on Monday morning, which gives me some time to continue going through the book and getting on to the next stages. So if you want to see these, please follow me here on Twitter, on YouTube, any of the places, or you could just sort of hang out when you see it. It's all fine by me. I hope that you all have a great rest of your day and a great weekend, and I'll see you next time.